Now we'll take some example. Suppose we want to roll 2 die simultaneously. For first die we want 2 and for second die we want 5, and the event C is sum of the two outcomes. So what is the probability of event A? Obviously 1 by 6, because event first die we are rolling the first die and the only one options to get to, so it should be 1 by 6, and for B, event B, it is only 1 by 6. For event C we can calculate that only 6 way it can be done. So let's look into the table. So only the yellow portion identified 6, 1, 5, 2, 4, 3, 3, 4, 2, 5 and 1, 6. These are the 6 way. Only we can get 7, sum of the two outcome 7. So there are 36 possibilities and we will get only 6 ways. So PC should be 6 by 36, that is 1 by 6. So what will be the whether A and B are independent or not, we have to check this. So we will find PA given B. If B is given, then PA is 1 by 6 always, because B does not depend on A. So in that case, PA given B equals to 1 by 6 equal to PA. So it matches our condition. So A and B are independent. Similarly, PB given C, we get 1 by 6 and that is equals to PB. So B and C are independent. And last, PA given C is also 1 by 6. So PA equals to PA given C. Show that A and C are independent. Now one question is that whether probability of B given B, we will get the probability of B given B equals to 1, because whether B has already occurred, that means there is a 100% chance that the probability of B given B equal to 1. We will take another example with an addition of new event, that is D equals to 8, sum of two outcomes. Now PA equals to 1 by 6, similarly PB 1 by 6, PC 6 by 36. Obviously same we have already seen. For D, it is only 5 combination is there, 2, 6, 3, 5, 4, 4, 5, 3 and 6, 2. So the probability of D event is only 5 by 36. Now we calculate PA given D. So PA given D, there are 5 possibilities and out of that only one event is there where we get the event A. So it is PA given D, whether D has already occurred, and in that case PA is 1 by 5. So it is not equal to PA. So A and D are dependent event. Similarly, we can calculate PB given D, and B and D are dependent. Similarly, PC given D. In that case, if sum of two outcomes is 7, then it cannot be D. Or if sum of D is given, that means sum of two outcome is 8. So it cannot be 7. So probability P of C given D, that D has already occurred, is equals to 0. So C and D are dependent. So in that way, we can calculate that C dependency or independency of any event. Now we'll take another example that will help us to clear our ideas about dependency. Choosing a red ball and a blue ball from the box of a 10 red ball and 11 blue ball. There are two boxes, one has 10 red ball and other has 11 red ball. So event A is pick up a red ball and event B is a pick up a blue ball. Then what is the probability of PA? 10 out of 21, and PB equals to 11 out of 21. So PA given B, if we try to find the B has already occurred, that is we have already picked up a ball of blue color, then PA probability of picking a red ball equals to 0. So PA given B equals to 0. So that we can PA not equal to PA given B. So event A and B are dependent. If B is true, then we have a new information about A, that is A is false. So that means these two events are disjoint, but they are dependent. We already mentioned that the two events, those are disjoint actually, they may be dependent. So given the information of B, we have a new information on A. So disjoint events can be dependent. We will take another example of independent event, rolling a die. The sample space is 1, 2, 3, 4, 5, 6. We consider two events, event A equals to 2, event B 1, 3, 5. That is, we would like to see the odd number in a die. Two event A and B, so they are separate event, there are no intersection at all because the two elements are different, and we calculate PA or B. What is the chance of getting A or B? So it is a PA plus PB 1 by 6 plus PB, 3 events, 3 elements, so 3 by 6, that is 4 by 6. And what is this is in this case we are saying it is a OR, but this is inclusive OR, because it should be actually A and B, P, A and B. In that case it is true. So or in English it is either A or B, but in actual probability A or B means A and B. We have to consider this thing. We will take another example with the rolling a die. The sample space is 1, 2, 3, 4, 5, 6. We consider two event A 2 and 6 and event B 2, 4, 6. So we will consider event A and event B. These are made some intersection. So we will calculate P, A or B. So in that case we will calculate PA plus PB minus PA and B. So we have to subtract the intersection event, that is if we look into the elements of A and B, only 2 and 6 is overlapped. So in that case we have to subtract the two event probability of two event, that is minus 2 by 6 from the PA plus PB. So you will get the probability of PA or B equals to half. Now we will apply some new principle of in probability, whether inclusion or exclusion. For two events, if A and B have an intersection, in that case A union B equals to A plus B minus A intersection B. Similarly, we can say intersection B equals to A plus B minus A union B. And for three events, A, B, C, three events made some intersection, and we can use that formula A union B union C equals to A plus B plus C minus A union B minus B union C minus A union C plus A union B union C. We have to add that A union B union C, because for in subtracting A union B and B union C and A union C, we have subtracted the one area twice. That's why we have to add A union B union C, the center portion of the figure of the picture. We have subtracted 2 times. That way we have to add 1 more times. So we will take example for two events. We will take example how many numbers have at least 1 3 and at least 1 4 within 0 to 999. By using this simple theory, we can calculate very easily. So event A, there are the numbers, there are thousands number is there. So number with no 3, it should be 1000 minus 9 to the power cube, it should be 271. And number B, for number B is same, 1000 minus number with no 3 equals to 271. A union B means number with no 3 and no 4. There are total 1000 number and 8 possibilities is there. So 1000 minus 8 cube equals to 488. Similarly, so we can calculate A intersection B equals to A plus B minus A union B. That means 54 number is there where at least 1 3 and 1 4 is there. So we take another example of 3 events. How many whole numbers between 1 and hundreds are divisible by 2, 5 or 7? In childhood we have we did it in a different way. Now we will do it in a more different way. So event A, the number 1 to 100 divisible by 2, only 50 number is there, 100 by 2, and for B it is 100 by 5, and for C it is 100 by 7. But we have taken 98 because 98 is the nearest number to 98, which is divisible by 7. A intersection B, that is the number which is divisible by both 2 and 5, that is 2 and 5, that is 10. So it is divisible by 100 by 10 equals to 10. There are 10 number. For B intersection C, so the number B and C, 5 and 7, that is 35. The number divisible by 35, it is 100 by 35. Instead of that, we have written 70 by 35 because the nearest number which is divisible by 35 is 70. So 70 by 35 equal to 2. Similarly, A intersection C, 100 by 14, 2 into 7 is 14. So it is 100 by 14. Instead we write 98 because 98 is the nearest number to 100, which is divisible by 14. That is 7 number is there. We use that formula. And A intersection B intersection C, that is 2, 5 and 7, that is 70. The only one number is there which is divisible by 70, 70 by 70 instead of 100 by 70. So 70 by 70 equals to one number we will get, whether only which is divisible by 70. So use that formula, A union B union C, A plus B plus C minus A intersection B, B intersection C, and A intersection C plus A intersection B intersection C. So that is 66. So only we will get 66 number, which is divisible by 2, 5 or 7. Now we take some example of without replacement of an event. So pulling a 4 hearts from a deck of cards. Pulling a 4 hearts from a deck of cards, we have a 52 number of cards in a deck, and we want 4 hearts for an event. So what is the probability of getting getting 4 hearts without replacement? So for it is PA equals to 13 by 52, because the first draw it is total 52 cards and there is 13 hearts. If first event is occurred, that is we get the first heart, then in that case the next event there are 51 cards and 12 hearts. So it should be 12 by 51, and consecutively 11 by 50 and 10 by 49. And if you multiply, the only chance is 0.2% for getting 4 hearts from a deck of cards consecutively. We take the same example with replacement, pulling 4 hearts from a deck of cards with replacement. For the first card, we have a 52 cards in a deck. So for the first card, the probability is there are 13 number of hearts, so probability is 13 by 52. For the second event, it is 13 by 52, because we replace the first card to the deck of card. So in that case, and for the third and the fourth, similar for third and fourth. So we will get PA equals to 13 by 52, 13 by 52 for second, 13 by 52 for third turn, and 13 by 52 for the fourth turn. So PA is 0.3% only. So for with the replacement, the chance of getting hearts is better than without replacement. If we remember, the value of the probability of the event A without replacement is only 0.2%, but with replacement the probability is 0.3%. We will take another example of the probability, what we have learned already. Tossing a coin, the sample space is very simple, head and tail, and at least one head in n trials. So we are trying to get at least one head in n trials, and maybe 2, 3, 5 and any number. So n is an integer here. So in that case, we can calculate the probability at least one head equals to total probability 1 minus p no head. If the trial number is n, then we have to calculate p no head to the power n, because for first event we did not get head, that is the probability of getting tail is half. For the second event, as the event are independent, we can say at the second event for it is the probability is half also. So in many times if we calculate this, it should be half to the power n. So if we take the probability 8 trials, then in that case p at least one head would be 1 minus half to the power 8. So 255 by 256. We will take another example, rolling a die, where rolling a die, the sample space is 1, 2, 3, 4, 5 and 6, and we would like to get at least 1 6 in 4 trial. So what is the chance of getting 1 6 in 4 trial? It can be easily calculated with the help of at least one rule. So p at least 1 6 equals to 1 minus p no 6 to the power n. To the power n is a number of trials. So if we use the 4 trial, then it is 1 minus 5 by 6, because 5 by 6 the probability of getting other number other than 6. So it should be 5 by 6. So 1 minus 5 by 6 to the power 4, that is only 0.5177, that is 51% chance. So if you want to bet with your friend, then you have to at least consider at least 4 trials, so that the probability is more than 50%, and in that case you will win, otherwise your chance of losing is high. So calculate the probability and go with your friend and bet using the theory of probability. We will take another example which is very interesting, that we want to roll a die and we want a 6 of any trial. So how many trials are required to get at least 99% chance to get at least 1 6? We want to calculate this. So p at least 1 6, so that's the probability is we want 99%, that is 0.99. So it should be at least one rule, 0.99 equals to p 1 minus p no 6 to the power n. So if we calculate the value is n equals to 25.26. So at least 26 trials are required to get at least 1/6. So if you want to bet with your friend, then you have to select this number at least 26. Do not take it is 24 or 23 or less than that number. In that case you will lose, because in 26 trial it is 99% chance that you will get you will win. Now we'll take another example that is very interesting, rolling 2 dice simultaneously. So if we roll 2 dice simultaneously, these are the sample space, that is the 36 possibilities is there. So 1 1 1 2 and so on up to 6 6. There are 36 possibilities. Now we calculate the probability of calculate the probability of getting 2 6 in the 2 dice. So what is the probability of 2 6? If we use the at least one rule, p double 6 equal to 1 minus p no double 6. So no double 6 is 35 event is there out of the 36 events. So 1 minus 35, we have taken n equals to 24. So we'll come to that why we taken n equal to 24. You can take any value of n in that case. It is only 49%, that is 0.49. If we take the value of n is 25, in that case the same event, the probability of same event is 50.50, that is more than 50%, and for 24 it is less than 50%. So your chance of winning is more than 50% if you take the trial is number of trial is 25%, 25. And so if you want to bet with your friend, so in that case you consider the number 25 rather than 24, but because 24 the probability is 49%, and then in 25 the probability is more than 50%. So your chance of winning is high if you take the number of trials is 25%. So use the probability.